Let's solve the exercise number 7 in the part B of data structure lab. In this exercise, we are supposed to create a linked list and we are supposed to perform the following operation. First one is to insert a node at the end. Second one is to delete a given node. And finally, we are supposed to display the content of the singly linked list. So let's try to create the singly linked list. Now, before we proceed, let's just recall what is a singly linked list. So, singly linked list is nothing but a single link connection between the number of nodes. So, there will be a node which has this structure. It contains an info. This could be any data like integer or string or anything. So, there will be some info and there will be a pointer that points to the next node. For example, you have a data here and it is pointing to the next node. This procedure continues until we have the last node whose next pointer will point to the null, indicating that the last node is grounded or the last node is terminated. Also, there is going to be a special node called as a head that points to the first node of the singly linked list. So before we proceed, let us try to create this structure. That is a structure that contains an info and a pointer to the next node. So let's go ahead and let's create it. I will start the code block and I will click on the new file and I'm going to create a new file here. I will select C++ as the source code. Let me click next and I will select C as my programming language and I will go here and I will just call it as yes. You can call it any name of your choice. Let me click next and then finish it off. As usual, any C program will have include stdio.h. So I'm going to go with the standard include stdio.h. So std, what is this one? stdio.h. Okay, done. And then let us start creating the structure. So I start with the structure and I will call it as end, and it has two parts. I assume that the data that is being stored, that is the information that is stored here, is integer. So I'm going to take it as an integer. So I'm going to say int info, which is going to be a data that is stored in it. And I need a pointer for the same structure. So I need a pointer for this structure. I will call that as next. So this will be the pointer to the next node. Now, every time whenever I want to create a variable of this type, I have to write this whole story like struct nd and a variable x. This is going to be a laborious process. So I'm going to rename this struct nd as a node. So how do I do that? I'm going to use the type def. So I'm going to say type def struct nd as a node. So from now onwards, instead of this struct nd, I will refer it with the name node. So let's try to create a variable. So if I want to create a variable, I start with the node, which is nothing but struct nd, and I need a pointer to the starting location, and generally we call this one as head. So this is one pointer that I require. And whenever we create a node, we need a pointer. So let me call it as every node is referred as n. For the time being, let's these two are enough for us. So let's start creating the nodes. What are the things that we are supposed to create? So if at all I want to create a node, I must know what is the integer value that has to be stored here. For example, if I want to create a node here, then I must know what is the value like 50, 60, 70. What is the value that I want to store in this one? So I need some integer x. X could be anything that I can store it inside this node. So let me go and create a function for that. So let's say void insert int x. So this x will be the node that I'm going to create. Now the first thing I want to do is I want to get the allocation for this in the memory. So I have to get the allocation for this node inside the memory, and for that we know that we have malloc function. So I'm going to call malloc, and what is the size? Size of the allocation that I'm interested in is the size of the node. And what is this node, by the way? It is the structure. In other words, I'm telling the compiler that, or I'm telling the machine that I want this much of a memory to be allocated to me. So it's going to allocate that memory to me, and I'm going to store it in the pointer n. So with the pointer that n I have just created here. So this n I have just created here n. This is a global variable, and I'm using it here. So it will be available to me everywhere because it's a global variable. So let's do the next part. Inside this n, I want to store the value x here. So n.info is x. So this is what I'm doing it. So I'm storing the x value inside this. What about the pointer? Now it is not pointing to anything. So I'm going to say it is pointing to nowhere. So nowhere is nothing but a null. So I'm going to say n dot next is null because it is not pointing to anywhere. Okay. Now I have to place this inside this linked list. I have to connect it to the linked list. I'm going to just pull these values from here. Let me just take this one, all of them. Let me take all of them out. Okay. So I have to connect to the head that is starting. This is the first one. So I have to connect it here. Okay, so the end part is it is not pointing anywhere, it is null. So this whole thing has to be somehow connected to the head. How do I do that thing? So I'm going to say if generally, see, whenever you create this head, let me initialize that head as a null. Let me initialize this head as a null. Let me then create these nodes. Okay, I just initialize the head equal to null. That is the initial value. Head will be null because initially there won't be any pointer as such. Head is not pointing anything because the linked list itself is not there. So I just created this head is null. Let me go ahead and you can write it here itself. Put a comma and write it here, but I will keep it separate. Okay, so let's go ahead and let's do the other part. Okay, where is this thing gone? Okay, so initially, you know that the head is null. So that means to say that initially, let me just pull it out. This is my head. So head will be null. Okay, head is null, and this is also null. Okay, and let it be this was already null. This was a previous one. This has nothing to do with the current explanation. So let me keep this one. Now head is pointing null because I have initialized it with the null. Okay, so now I have to check whether the head is null. If the head is null, just connect it here. Just place it here. Let me remove this. Just place this node here. So let me first check that thing. So I'm going to go over here and I'm going to say if, let me go here. So I'm going to say if, okay, if my head is null. So that means to say that there is nothing in the list. If that is the case, then head will be pointing to the new n that I have just created. So the new n that I have just created here, so the new allocation that I have just created with the value 15 or whatever it is. So my head will be pointing to this one directly. So my head will be pointing to this new n that I have just created. So this new n I have just created, head will be pointing there. This is the first case. What about later onwards? From now onwards, because now onwards head is not null, because head is pointing to something else. So now let me go back here. Now the head is not null. Head is pointing to something else. Now what did they say? So let's look at what they have said. Let's go back to their story. They said that insert the node at the end. So I am supposed to, suppose if I create one more node, let me just create one more node. Let's say I'm creating one more node. This is not really required. Okay. Suppose if I create one more node, say 25, then what I am supposed to do? I'm not supposed to place it at the head. I'm supposed to place it after this null. After this thing, I'm supposed to connect after this. Okay. So if it is head is not null, then I have to find the location where that last node exists. So let's say you have three nodes. Let's assume that you have three nodes now. Somehow magically you created three nodes here. And you know very well, last node is grounded, so it will be null here. So suppose if I want to place the fourth node here, so let me say this is 45 here. Then what I have to do? I have to start from the head. I have to go to this one. I have to go to this one. I have to go to this one. And when I jump from here, I will encounter null. That means the list is ended here. The minute I get the null, I know that the list has ended. Then I have to make this null pointer point to this new node, and naturally the other part will be null, the end will be null here. So I have to locate this null. Null indicates where the list has ended. So go up to the null, that means go up to the end of the list and then try to insert it there. How can I do that thing? For that, remember, I can simply move the head pointer here. If I start moving the head pointer, I will lose the starting of the list. So I'm going to create a temporary variable. Let me call that temporary variable as a star t. You can call it as a temp here, but I will call it as t because it is easier to type t rather than temp. So that is the reason I took it as a T, not the temp. You can type it as temp also. Then you have to type four letters every time, and it will slow down your execution, okay, of the code during the examination. So I'm going to say that I will take a temporary node. Let me take T, and I will make it point to the same location where the head is pointing. So that means I'm going to point it to the front of this linked list. So this T pointer will point to the same location where the head is pointing. How do I do that thing? I'm going to say T is equal to head. That means T and head are now pointing to the same location. So T is also pointing to the same location. Then what I am supposed to do? I have to move this T continuously. I have to move this T from here to here to here until I get the null. So until I get this null, okay, I have to move this one. Where do we get the null? Null is there at the next. So this is the next pointer. So this is the next pointer. So this next pointer, if it is null, then I have to say that I have reached the end of the list. So initially, T and head will be pointing to the starting location. Then move the T by one location. So use this next pointer, move this T to point to the next location. Check whether the next is null. If it is not null, again move this T to the next location. Again check whether this next pointer is null. If it is null, that means you have reached the end of the node. That means you have reached to a node that is the last in the linked list. So you have reached your destination, in other words. Add the node at this location. So what you're doing is you start with the T, you point the T to the first node, check whether the next, this is the next pointer, whether the next pointer is null. If not, go to the next node. Again check whether the next node is null. If not, go to the next node. Check whether the next pointer is null. If the next pointer is null, that means you have encountered the last node of the linked list and you are supposed to add the new node at this point. So how do I say that in C? So I'm going to continuously iterate, and you know very well for continuous iteration we use the while loop. So I'm going to say T dot next. If it is not null, I have to continuously, null in capital, I have to continuously go. So in other words, until, if this t is pointing here, until t dot next is not null, I have to keep on moving. The minute I get t dot next is null, I have reached the node where the new node has to be inserted, or I have reached the end of the linked list and I am supposed to insert a new node there. Okay, so that is the idea there. So as long as t not next is not null, keep on moving. How can I move to the next node? So how do I move to the next node? Remember, t is pointing here. Let's say t is pointing to the this node now. Initially, t and head are pointing to the. How can I go to the next node? T has to go to the next. So the new value of t is old value of t. What is the old value of t? The starting location. And next, what is the next node will indicate? This next, this is the next node. Next node will give me the location of this next pointer will give me the location of the next node. So it is going to give me the location of the next node. So when I say t dot next means I am actually getting the location of the next node. So the t now will be pointing to the next node. Again, t dot next means t will be pointing to the next node. So t is equal to, this is what I'm going to write, a new value of t is equal to old value of t and the next value of the next pointer. So this next pointer, you know very well, next pointer will be pointing to the next node in the list. Next pointer will be pointing to the next node in the list. So that is what, so in other words, I am moving t from this node, I will move it to the next node. So this is what I'm doing, and I will repeat this process until I reach the next node. Now, a good part is during the examination, instead of writing this flower bracket, because there's only one statement which is there, you can omit this flower bracket. Remember, if you are getting confused, put the flower bracket. This is the only one statement that is part of the while loop. So in that case, there is no need to put the flower bracket. However, if it is confusing you, that while loop must look like this, for some people are there, for them while loop must look like this. So if it is if you are of that type, you just put the flower bracket. But my personal advice is don't waste your time during the examination. Try to put the unnecessary flower bracket and extend the time, so that is not required. So you just this indicates that while loop starts from here, it ends here. So this will be your continuous while loop. Okay, one statement is there within that while loop. Now when we come out of this, when do we come out of the while loop? When you reach the null. So it is, as long as the t dot next is not null, this while loop will iterate again and again and again. So when the next pointer becomes null, t dot next becomes null, you have reached the end of the list. So when I come out of this while loop, the t will be pointing to this last node, whichever is the last node. Okay, in this case, this is the last node. For that next, this t dot next is null. So this null has to be made to point to this new node. So how do I do that thing? So I come out of it and I'm going to say t dot next, which is, remember, t dot next in this case, t dot next will be pointing to the null. T dot next is null. This I will point to the new node that I've just created. So I have created the new node here. Can you see that new node? I'm going to point t dot next to that one. So I'm going to say t dot next is n. After that, just to tell the user that I have completed, I'm going to use the printf statement. Not really required, but I'm just going to use it for brevity. So I'm going to say, okay, element or node inserted. Let's say node inserted. Okay, maybe slash n. Done. Node inserted. So I know that one node has been inserted. So this is the insertion part. Okay, let's do the next part. What is the next one? Delete a given node. So what is the meaning of delete a given node? Suppose you are given a node here and they will tell you that delete a node with the number 25. So delete it. So they will tell you which node. Delete a node means delete this node with the number 25. So you need this number to delete it. So let's write the function. I'm going to say void delete and I have to give the value. So let's say I want to delete a value. Let's say key. You can X or anything. I want to delete this key. So I use the word key there, but you can use anything there. Okay. So this key, I want to delete it. Okay. What is the procedure? You start with the node here. Okay. You start with the beginning T. Okay, you make this T as usual. You start with the T, make the T point to the new node. Every time you go to the individual node, you check whether this value is equal to the key. That is, key is the one that we want to delete, whether it is matching. If it is matching, delete it. If not, go to the next node and then check whether this key is matching with the key that is given to us. If not, go to the next and keep on doing it. So initially, let's start take a temporary pointer T, which will point to the beginning of the list. How do I make that? I already have a T here. I already declared that is a temporary variable. I will say T is pointing to the same location where the head is located. So initially, both the T and head will be pointing to the beginning of the node. That's it. Now, if suppose somebody says delete the node with the key 15. So delete a node with the key 15. You notice that the key is already there. Head itself is pointing to that. That means it is the first node that I want to delete. If it is the first node that to be deleted, then there is no need to go with the iteration. And you know very well, for iteration, you need while loop. So there is no need to go and waste your time with the while loop. So if it is a first node to be deleted, then you can easily do that thing. So that is what I'm going to check here. So I'm going to go over here and I'm going to just check if it is the first node itself. What is the meaning of it? If the head dot info, that itself is the key. That means to say that somebody said, remember, what is the first node here? Head is pointing to 15. If suppose somebody says that you want to delete a node with the key value 15, so that means it is the first node in the list. So it is easiest to delete this node rather than making the things complicated, because it's the first node to be deleted. It is easier. How can I delete this one? Remember, initially T and head are pointing to this 15 and we want to delete this 15. So what I'm going to do is I'm going to move this pointer of this head. The head was pointing to this, and you know very well this next is pointing to the next node. So what I'm going to do is I'm going to make this head point to this one. How can I make the head point to this? This one is this node has a pointer that is pointing to the location of the next node. So I'm going to say head is pointing to this node. Head is pointing to this node. So this is this dot next. This is the next pointer. This is the next pointer. So this next pointer is pointing to the second node. So I'm going to say head will point to the next node, whatever the next is there. This is the info. Remember, this is the info, and this will be the next pointer. So head was pointing to this. Head will point to the location pointed by the next node. In other words, head will be pointing to the location pointed by the next node. What is the next node? Is the second node. So head will now point to the second node directly. So this node is vacant. So it is disconnected from the linked list, but it is not deleted. It is disconnected from the what to say your thing. So now head will be pointing here. What about this one? This will also point to the same location. Only thing is head is now pointing to this location. It is still there. You have to free it from the memory. So let's see how it can be done. Let's go over here. If it is that case, if this is the case, then I'm going to say head is equal to wherever the head is pointing, the next of that head. Head is moved by one position. In other words, head is, if I just keep it here, head is moved by one position. So head will point to the next. Okay, done. Now, what about what if this is the first easiest case? What if somebody says, I want to delete the 25 or 35? What if I want to delete 35? Remember, both the head and the temporary pointer is pointing to this same location. So I need two things. I need one to point to the this node, and I need one more. Let me just extend this linked list a bit further. So I'm going to just take few of them from here so that I can explain it in a better way. So let me say this is 40 and this is 60, whatever the value, and the last one is a null. So if somebody says I want to delete 40, what you have to do? Initially, you start with the head and temporary pointer pointing to this location. You go to the next, you go to the next, you go to the next. So this has to be deleted. What is the meaning of saying this has to be deleted? The 35 is pointing to 40. This pointer has to be made to point to 60, so that this is disconnected from the link, okay, or it is disconnected from the chain. Then free this thing. So I need to know which is the previous. This one has to be deleted. Suppose I need to know which is the previous node which has to point to the next node. So which is the previous node? I need one more pointer that always says which is the previous nodes. The next, this is the previous node. The next node has to be deleted. So I need one more node called as a previous node. So I'm going to create one more variable here. I will create a global variable directly here. That is easier. So I will create one more pointer star p, which is a previous. You can write it as PRVE. So you can write 4 letters, but you can avoid writing four letters in the examination by making it short as P. So previous. First thing is we must know, let's say T, let's say this is the pointer where T is pointing. This is a temporary pointer. Okay. Initially, temporary pointer and the previous pointer will point to the same node. You move the temporary node to the next node. Okay, check whether this is the key. If it is not the key, okay, move the previous to point to this node. Okay, now move the say color. Let me change the color. Move this T to point to the next node. So the previous node is always lagging this temporary node by one. It is behind, one step behind the temporary node, so that I can get rid of, I can take this pointer of the previous node and make it point to the next node. Okay. Always the previous node will be lagging. So that is what I want to be done. So let's go here and let's try to analyze the situation. So I'm going to write this else part now. I need one flower bracket because there will be more than one statement. So what I'm doing is I will keep on searching for the key. I will start with the temp. Okay, I will keep on searching whether the key is, suppose if the key is 40, that means they want us to delete the node with the number 40. I check whether this 40 is matching. No. I will make the T point to the next. I check whether this is matching. No. I will make the t point to the next, whether this is matching. No, I will make it point to the next, whether this is matching. If it is matching, that means I have to delete this node. So as long as this key is not matching with the info here, this is the info, you know that this is the info. As long as the key is not matching with the info, you have to keep on moving this t to the next node. So let us write that part. So how do we write that one? So while okay, t dot info okay, is not equal to null, is not is not equal to key. Okay, that is the thing. If it is not equal to key, you have to keep on doing it. However, there is one other problem. Why that null came into my mind is, however, there is one problem. The problem is, initially, let's say t is pointing here, the first node. What if somebody says delete 90? The key given to you is 90. So delete the node with the key 90. Now you start with the t equal to 15. It is not matching. You go to the next one. This is not matching. You go to the one. This is not matching. You go to the next. This is not matching. You go to this one next. It is not matching. You go to the next. What you find is null. Okay. That means the linked list has terminated. The list has ended. Okay. What is the indication? That means 90 is not found in this list, and you can delete it. If it is not found, you can delete it. So first thing is, see whether we reach the end of the list. If you have reached the end of the list, that means it is not found. So first thing, we will check whether it is not null. The t has reached the null, that means the element is not found there. So I'm going to write that part also. So the first thing I'm going to write is, if t has not reached the null, okay, and this part, second part is no, as long as the key is not. So both the conditions are, this is not this. If the key is not null, that means you have not reached the end of the list and you have not found the key element. You have to keep on moving next. So this is the while loop. Done. Now what is the next thing? Remember, initially both where is this? Initially both previous is pointing to the previous location. Previous and t are pointing to the same node initially. Then one step back. So every time. So let's go ahead and let's do that. Initially, both P and T are pointing to the same location. Then what you are doing is you are moving if it is not matching. So initially, both T is pointing to this location and P is also, P is previous, this is temporary. So P is pointing to the next. Then you make this T move to the next one. When t is pointing to the next one, previous is one behind the temporary. So that is called previous. Previous is one behind it. So how do I make a t point to the next? You know very well. If p is now pointing to this one, p dot next will give me the next location. So move the t by one step. How can I move? T is equal to old value of a t and the next point. So this t is pointing here. Okay. How can I move? Take this next pointer and go to the next location. So next pointer and go to the next location. That is what I'm doing. Next pointer, go to the next location. You keep on doing like this. Two things can happen when this while loop is iterating. Two things can happen. Either the element, so t is pointing here. So t will go here, and t will come here and say that the item is not found. Or he will start from here, it will go here and say, okay, eureka, I found this. I say that, okay, I found it. Either you find the element, or you end up in null. That means the item is not found. So let's go with the Positive note. What is the positive note? If it is found, then we will do it. Suppose if it is the negative part, what is the negative? Negative is you start with the t. Okay, you check whether this is 15. No, it is not matching, it is not matching, it is not matching, it is, you jump, and then you jump to the well, jump into well, this is null, you lost the game, the list has ended, and you say that it is not found. So if t is null, it is not found. So let's start with that bad node. So we are going to say if t itself is equal to null, that means to say you that item is not found. So we are going to give a printf message, and we are going to say that element is not found, or okay, key is not found, and we are going to, or element is not found, whatever you say, node is not found. Let me make it as node is not found. Okay, there is nothing much you can do after this. If it is not found, just come back, return back. There is no need to proceed. If it is not there, what you can do? Okay, suppose if it is not this case, that means to say that you started with the t. Okay, you started with the t, you jumped here, you jumped here, and you jumped here, and you found it. Okay, that case, when you find it, remember previous is pointing here, the previous node, t is pointing to this one. So make this previous point to the next node. Next node, how we can point to the next node? Whatever the t is pointing, take that next node. So p dot next, what is this p dot next? P dot next is this one. Let me make this one. So t is pointing here now, and p is pointing here now. Okay, so you have to make this pointer point to this one. Whichever t is pointing, where is the t is pointing? T dot next is pointing to 60. You have to make this p dot next, which is pointing to 40. This has to make to be pointed by this location. So that means to say that where p dot next is pointing to 40, to break that link and make this one point to the location that is pointed by t dot next. Where is t dot next is pointing? Is pointing to 60. So p dot next has to point to the location pointed by t dot next. So let us write that one here. So how we can write p dot next is to be pointed by the location that is pointed by t dot next. Okay, that's not the end of it. And what is that we are supposed to do? We are supposed to free that temporary node. Remember, it is not enough if you make this one point to this one. It's not enough. You have to remove it from the memory. How can you remove from the memory? You know very well. You say free the t. So what is the meaning of saying free the t? Is you go and tell the operating system that allocation, you remove it from the memory. So in the memory there is one allocation for this t, remove it and use it for something else. Okay, if you have successfully completed up to this point, you print and say that node deleted. Okay, node deleted. Okay, done. Okay, that is for deletion. What about the display? Let us write one more function. What is the one more? This is the easiest function, void dot display. Here write this function. So let's say void dot display. Now whenever we want to display, we are supposed to give the starting location. We have to give the head location. So you start from the head, you print this value, go to this, 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 print this value, go here. This is going to be hell, and you just stop here. Okay, you start from the head and start doing it. So let's go ahead and let's do that. So I need a pointer. So I'm going to say node, and don't get confused. This is just a pointer. If you want, you can just call it HP, but I'm going to call it as head. Just to say that you have to start from the head, the starting location, head point. Now, suppose somebody fools you, and suppose in the initial stage, you know very well, head is pointing to null. Initially, when the list is not there, when you start right at the beginning, when the program starts, you know that head is initialized to null. If that's the case, the list is empty, is it not? So we take care of that thing first here. So if the head is equal to null, okay, we're going to say if the head is equal to null, then I'm going to say print f, and I'm going to say what you can say /n. I can say list is empty. Okay, done. And there is nothing much to be done, so I'm going to return it because there is no list. What you can do if there is no list, is it not? I think I have which is this one. Oh, this just a minute, I think there is one. This is for this okay, there is one dangling. I just saw that there is one dangling pointer is there. Okay. So this one is for this let me zoom in a bit. This is for this closing bracket. This one is the closing bracket of this, and the last one is that is why I just got sorry, I just got one dangling closing bracket, so that I just got confused. Where is this thing came from? Okay, so let's go with the other part. What is the other part? If it is not null, if it is not null, that means there is a list. So I'm going to say, I'm going to print, and I'm going to say printf. I'm going to say /n list is okay. I'm going to just put I will put one space here and start. You start from the head and you keep on moving. You know very well. You keep on. Where is this thing gone? You keep on moving until you reach the null. Until you reach the null. So as long as the head is not reaching null. So while head is not reaching null, head is not reaching null, you keep on doing it. What are the things that you are going to do? You print the value. So you print the value of this. What is the value you are going to print? Initially you print 15, then you print 25. You print the info which is there in the node. So you keep on doing it. So you will print %d, %d, and you must put one space here, otherwise they will touch, the values will touch one another. So remember to put a space here. After this %d, one space should be there before the double quotes, otherwise the numbers will touch one another. You print the info. You print the info. So head is pointing to 15. You print this info. Next, move the head to the next location. How you can move the head to the next location? You say head, new value of the head is old value of the head, and wherever it is pointing. So new value of a head is old value of a head, and wherever it is pointing. So it is going to point here. This is going to point here. Don't get confused. I am not moving this head, the original, the main head. I'm moving a separate head. This is a local temporary variable. If you get confused, just make it as HP. Okay. So this has nothing to do with the, where is it? This head. That head is different from this head. This is a local variable. Okay. Hope you are familiar with the local and global variable. Okay. You keep on doing it. And what is the last thing? So just to tell you that, so it will print like 15 space 25 space, it will print like this. At last, I want to print separately, say that list has ended by printing a null. So I'm going to just say after this while loop, I'm going to say print f, and I'm going to print null. I'm printing it. I can print money here. This is, I can print my name here. So money. Okay. So it is, I'm printing null. Instead of that, I'm printing null. This is just the word null. Okay. This has nothing to do with that null which you are using in C. It is just the word in double quotes. It done. So all are done. Let's go ahead and write the main program now. So it is going to be very simple main program now. Let's start with the main program now. Before I just minimize and see whether my closing flower brackets are all proper, because I got one dangling flower bracket. Hopefully the things are proper. Okay, so let's go ahead and let's write the main now. I'm going to say void main. Okay, what are the things that are required? I require n value. So what is this n value? That is the key value. You can use that key value. You have to accept the, ask the user, what is the value? 15. What is the value? 25. What is the value? 35. I have to ask that n value. And there are three things that we are supposed to do. What are the three things? Either you can insert it, either you can delete it, either you can display it. So the choice, what you want to do. I want to add, I want to insert, I want to delete, I want to display, or I want to exit. That is the choice of the user. So I need two things. One is that n, other one is the choice. Okay. Then I'm going to use a do while loop. So do while loop. So as long as the choice is, the first choice is to insert, second choice is to delete, the third choice is to display, fourth choice definitely is to exit. So as long as the choice is not equal to 4, you will repeat this while loop. Okay. First we are going to print the menu for the user. So I'm going to say choice number 1. Choice number 1 is insert. Okay, slash n. Choice number 2 is delete, slash n. Choice number 3 is to display. Okay. Choice number 4, let's put that, is exit. Okay. Then slash n dash 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 dash. I'm going to put some dashes here. Okay. And slash n your choice. Okay. So let me just, okay, your choice, and I will put a space here. So this is how it's going to look like. So it will come in the menu one after the other, and your choice will. And I'm going to ask the, I've already asked the user, your choice. So I'm going to say percentage %d, and I'm going to read the choice. So this is ch is the choice. I'm reading this choice. So read the choice. I will use the switch statement for the choices. Case number 1. What is case number 1? Insert. Case number 1 is insert. So how do you insert it? I'm going to ask the user printf. Let me use slash n. Enter a number. So let's say I put a space here also. If you notice, it looks nice when you put one space after that. Let's use scanf, and I'm going to read the value of n. So I read the value. So the user says 15. So if the user says 15, create a node for 15 and insert it. How do you insert it? So I have the function. What is the name of the function? Insert, and I'm going to supply that n here. After that, I'm going to take a break. Done. Let's go to the choice number 2. So let's go to the case number 2. Case number 2 is, what is the case number 2? Delete. So again, I'm going to ask the user, what is the number that you want to delete? Now, before I do it, I'm going to just check whether the head is null. What is the reason is, if there is nothing is there in the list, if there is nothing, if the head is null, and if the user types it, I will not check for this, and I'm going to do that. I'm going to simply say that there is nothing. If the head is null, means the list is empty. Okay. So I'm going to go over here, and I'm going to say if the head is null, if the head is null, okay, I'm going to print and say to the user without doing anything. I'm going to simply say to the user that the list is empty. List is empty. Okay, done. Okay. Otherwise, if the list is not empty, then all the stories that we have to say, then I'm going to say, I think I will get this one. I'm going to copy this whole story. I need a number, so I'm going to just get that number. Okay. I need this number. Need a number. The number is the key. I want to delete 40. I want to delete 50. Which one you want to delete? So enter a number 15, and that has to be deleted. Okay. How do you delete it? You have the function, which is the name of this function, delete, and you delete the en. Then let's take a break after that, and then let's go to the case number 3. What is the case number 3? Display it, and there is nothing to be asked, so we are going to say display. What was the function name I gave? Let's check. Displ. Okay, this is proper display, right? Is it not? And let's display and take a break. Case number 4 is for exiting. You notice that case number 4 is for exiting, and we are going to say print f, and we are going to say /n exiting dash 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 and /n exiting. So we are exiting. If the somebody is over intelligent and if they type something which is let me put a break here after that. And if this person is over intelligent and if they type something else, we are going to say printf /n wrong choice. Okay. So any other number, that means it's the wrong choice. And that's it we are supposed to do with that. So with that, I think switch case is over and while loop is also over. Done. Let me keep my finger crossed and let me try to run it, see whether I have some problem. Now, if you get like this in the examination that you don't understand why it has stopped here, what are you going to do? You go here to the view and then click on the logs. It is going to tell you that too few argument. So you know very well display. If you look at this display, there is a display story. You have to give the head. You have to supply the head. I didn't supply the head. So let me supply the head to the display. So starting point. Save it and then see if there is any other error. I use the print. Now this is going to be very well story. Where is the print? Okay. Somewhere I have used the word print. No, it is not. Did I get the line number? It is not showing me the line number also. Okay, print. Somehow I got it. Okay, done. Okay, this is what you're going to get. So first choice, second choice, third choice. Choice number. Let's try to display it. And what you get, a list is empty because there is nothing is there in the list. Let's try to delete it. List is empty. Okay, after list is empty, we are not getting anything back. Right. Okay. So list is empty and it has just stopped. Whereby what is the problem? List is empty. So this is the else part. So you get the list is empty and it didn't came back. What was the problem? Okay, if the case is still list is empty, we came here. After that, it didn't came back. Okay, let me just check. Let me do it to 2 here, and list is empty and it is not coming back. What is the reason? Let's look at what is the reason. So the reason is say this else part. Only this will be taken up. The other two will be there. So I just forgotten to add the flower bracket for the else part. In the else part, if you notice, there are three things that are part of the else statement here. And that else statement, if you look at it here, all the three things are part of it. If the list is not empty, you ask the user enter a number, scan that number, and then delete this number. All of them must be part of this else part. I just forgot to add these two flower bracket there, so please add those two flower bracket. That is why it was actually coming to this scanf statement and it was waiting. Okay, so let me, that is a logical error, by the way. So let's run it and let's try it one more time. Initially, if you display it, nothing is there. If you display list is empty, now start inserting. I'm going to insert the node 10. So enter a number, and I have inserted. Whether I have inserted, let me display it and see. Okay, so you notice that it has been the number has been inserted. Just to make it look proper, I'm going to just put this arrow here so that it looks like a linked list. So how do we, where do we make it? I'm going to just remove it. I'll go to this printing part, display part here, and after this D, I'm going to use the arrow like this. After D, I'm going to just put the arrow like this. Done. No, but I didn't get, if you notice, I didn't get node inserted. I didn't get that word, not this one. Node inserted. I didn't get that thing. Okay, so why I didn't get is this node inserted part. If you notice here, that is inside the else part. I'm going to select this, just drag it down. Okay, what did I do is, if you are wondering, see whether you insert it from here or whether you insert it from here. In both the cases, you have to say that is node is inserted. Now, when I keep this thing inside the else part, if I keep it inside it, don't do it. You just say, if I keep it inside here, then node inserted will come only for the else part because it is part of the else. But for the first time when you insert it, you won't see that message. So I'm going to just to pull it here and drag it out of this, which one? Out of this else part. So out of this else part, I'm keeping it here. So regardless of whether you are inserting from here or whether you are inserting from here, this statement will print because it has nothing to do with the if statement. So it's going to print here. It's done. Let me try it one more time. So one line I have just pulled it from here and I placed it outside the if. Let me run it and let's see. I'm going to insert the number 10. Okay, let me display it. Now what you notice in the display, you see an arrow here. Where is this thing on? You see this arrow. From where did I get this arrow? I got this arrow because in my, where is this display node, I have shown this arrow. This arrow is going to come. Okay, let me again insert one more node, 20. Okay. Let me display it by typing 3. You notice how it is coming. So first one, the second one, and the last one is null. So it's going to come like this. Okay, so if you want, I'm going to put one/n here so that you notice that it is coming very close here. So there is no line break here. So I'm going to just make some adjustment. Let me exit it. Let me make that one extra thing. So here after this null, I'm going to put /n, one extra line, so that the next thing will come next, one extra line. I put one extra line here. Okay, so let's run it and let's insert 10. Okay, now let me display it. Where is the thing? 3. And you see that there is one line here, separation, line separation is here, so it looks nice now. Let me insert 20. Let me insert again 30. Let's see it in action. So you have 3 nodes. Now I want to delete. So display is working. Let's keep our finger crossed with the last option, that is the delete option. I press delete and I want to delete 55, which is not there in the list. If you notice, it's not there in the list. First, let's see. So what is one node is not found. Okay, the 55 node is not found because it is not there. So let's first delete this head first. So let's first delete the head itself. So again, my choice is 2 and I want to delete the head. So the starting point itself. I press enter and you say node is deleted. Let me display it by typing here. You notice that a 10 is now removed out. Let me remove the last element. Okay, so let me remove the last element. So that is the 30. So 2 for deletion, 30 is the number to be deleted. Let me display it now. So only 20 is there. I'm going to add a few nodes here. So I'm going to say this one 40 is added. I'm going to add one more, 50 is added. I'll tell you why I'm doing it. Let me display it. Now you have the middle element, something which is there in the middle. I want to delete it. So let's go to, and let's say 40 is deleted. Let me see the list now, 3, and you notice that in between is been deleted. Let me delete all of them one after the other. So I will go with the delete 20, again delete 50, everything is deleted. I will go and display the list and I must get the list is empty. Okay, now even if I try to delete it, let me try to delete it. I press 2, I get the message as a list is empty. So that's all in this one. Somewhere I missed the logic, sorry for that. We will meet again in the next exercise. Thank you for your interest. We will meet again.